Hi everyone, it's Dr. Barden here. This is going to be a kind of short run through of one of the first presentations I'll be doing in the advanced topics class, which is just a kind of overview of the history and functionality of MIDI. This video is going to be, again, focused on the history of it. I'll have a separate one that's more of, okay, well, what's actually happening? How is the data protocol working and what's being sent to devices and all of that kind of thing. So this is going to be focused on the history of MIDI. Check out the next video for more of the how it works. So with that being said, I'm just going to kind of jump right into it here. I've got these slides are available on the Canvas course for the page, and generally speaking, information is coming from the history provided by MIDI.org with the MIDI organization, unless otherwise stated in the slides there. But they have a great resource for a lot of things MIDI related, so definitely check that out. Okay, so before we talk about MIDI, we got to talk about things that came before MIDI. And really before computers and electronic devices of the like. So modern MIDI as we know it came about in the late 20th century. It was released in 1983, but its roots and inspirations can be traced kind of as far back as 850s or so in Iran. Some brothers known as the Bonamassa brothers developed a lot of different mechanical devices, several of which were used to create and play sounds in a programmable manner, and it's debated whether or not that's like one of the first programmable computers. I'm not going to deep dive into that, but know that they had a steam-powered device that could play a flute, and you could program it to play different melodies. That's kind of the takeaway from that. But more people are familiar with things like the music box and the player piano. Those came out, significantly later in time, a lot more recently. But it's the same kind of idea where we can, have a pre-programmed set of instructions loaded into the instrument and use that to tell the instrument how to perform. That's kind of the theme of what's going on here with MIDI. So we're going to look a little bit more at player pianos than music boxes, but conceptually it's the same thing. So over here, I happen to have just a picture of a piano roll right here, and this is how player pianos and to a degree music boxes and things like that work. So this roll, this piece of paper with a bunch of holes punched into it, is the program that tells the instrument how to perform. You can still play the piano like normal and do all the other things manually, for lack of a better word, but you can load in this program and it will automatically do whatever it needs. So I'm not going to deep dive into all of that, but just know this roll is going to move past a particular, we'll say, sensor in the piano, and that will mechanically say, oh, there's a hole here, and that will trigger the note. And the longer the note on the paper, the longer the note is held for, and then left to right is pitch, low to high. So prior to audio recordings coming out, this was basically the way to reproduce music so that people could listen to it at home. So, you couldn't have an orchestra or go see an orchestra all the time, things like that, but you could get this, instructions and have your piano play the music. So it was great for people who really couldn't play piano and wanted to, people who wanted to check out music but couldn't get to the big places where all the music was being premiered, things like that. So I do have a little video here. I'm not going to play any of my videos in this recording for the sake of time, but these slides are in Canvas, like I said, so check it out. But this is just a little 7-minute breakdown of here's how some of the piano rolls are made nowadays. They aren't as common. After radio started coming out, player pianos kind of, got a little less popular because you could just turn on the radio. From there. But here's a few different examples that we'll listen to in class. Again, they can be fairly simple, straightforward. I think this is Mr. Sandman being played on the piano, but they can be a lot more complex in the realm of 20th century compositions is how I'll phrase that. This is something that if you took a composition course, you'd probably study it at some point here. But Conlon Nancaro was a Mexican composer who is really popular for his player piano works, and a lot of things he would do were intentionally significantly more complex than what a normal person could perform. So we'll listen to both these in class. This one's a lot more intense, and the idea is that a normal person could not play this. So we'll play around with that. A lot of fun to be had with those. I have a few other examples of an orchestrion as well, which you can think of as the next evolution of a player piano. Conceptually, it's the same kind of thing. You have your instructions for how to play, but instead of just a piano, I realized I forgot a parentheses there. There's a bunch of different types of sounds, kind of like an organ. It has, different pipes. Some sound brassy, some sound like reeds. There's percussion instruments involved, but you can trigger all of these to play their different notes. And it's basically an orchestra in a box. So that's, I think they're a lot of fun. And that's led to some modern interpretations as well. So I have some older ones and some newer ones that we'll check out in class. But just think of a player piano that does more than piano sounds. That's what we've got going on here. Following that, we start to see more electronic instruments becoming more and more popular. They started back in the late 1800s as people started harnessing electricity in different ways. I'm not going to deep dive into that whole realm of history, but there's a link here on the side to 120years.net, which is just a really great breakdown and timeline of the different electronic instruments that came out in this time period. And it goes all the way from, right around just before 1900, very into the 1800s, all the way up to 2019. So it's a very encompassing portion of that history. But there's a few things that came about from this that we need to address because these are problems essentially that MIDI would help to solve. So a few things. These instruments generally were not small. Technology, starts off big and gets smaller and more refined as we go. So these would sometimes take up entire rooms. They'd be exceedingly hot, full of vacuum tubes. Not fun. They usually didn't have a standard way to interface and play with the devices. Keyboards were common, but not standard. I mean, the theremin, you don't touch it at all. So things like that. It's not standard. It can be a bit of a pain, things like that. Keep that in the back of your mind. But as synthesizers and technology improved and developed over the course of the 20th century, it kind of led into our modern analog synthesizer, which this is where MIDI starts to actually become a little more relevant. So in modern-ish synthesizers, we're starting to see them. They're a lot more popular, a lot more accessible. We're seeing them a lot more in just music, all around. By this time, the need for a more standardized level of control was needed, but we're still, think like 1960s right now. We're not quite in the 80s when MIDI came up. But people were developing tons of different ways to control these electronic instruments. I'm not going to go through all of them because there's a lot, but just a handful. Actually, I say handful, really just one in today's slide, and that would be control voltage. I'm mentioning this one because it's still used a lot today in terms of synthesizers and things like Eurorack and the like. So this is basically, you could send a specific electrical voltage to your synthesizer, and depending on how much voltage is present is what the synthesizer will do. It'll respond to it in different ways. It can be, handy. I personally think it can be a little bit dangerous because you can get a lot of volts going if you're not careful, and if components start to fail, then you've got a lot of voltages and it's not behaving how you want, and you can go places you don't want it to go. But just a few different ways you can play, volts per octave, volts to hertz, things like that. So basically, as the voltage increases, the pitch increases, or other parameters would change. You can think of it that way. It's a very, very analog. And again, it's still used a lot today. We really won't be talking about it in class and things outside of MIDI for this, but just know that it's there. It's used to control synthesizers. And if you ever see something on the back of a device that says CV, that's control voltage. That's what it's doing. It's controlling things with a voltage. But let's talk about MIDI specifically. This was a very long multi-year process to get it going. I'm going to mention a handful of names here that you should at least know who they are and where they work with. But again, a lot of involvements in this. We're going to be more focused on what MIDI is and how it works. So if you do want to learn more about how it came about, I've got a link to this article right here that, again, from MIDI.org, great resource, breaks down in way more detail than we really have time to talk about. So check that out. But a few people to know, I'm going to butcher Ikutaro Kakekachi's name, but they were the president of Roland at the time. If you ever heard of the 808 and things like that, Roland, they make instruments. He kind of started the general process and reached out to different synthesizer manufacturers to be like, hey, there's this problem. All these synthesizers are different. We want to be able to, standardize this control in a way that, is useful to the people and also will make us a lot of money. I inferred that last part there, but that's generally how these things tend to go. Specifically, he reached out to Oberheim, who's like, hey, you should also bring in Dave Smith from Sequential Circuits and Bob Moog. Generally, they kind of work to create, okay, well, what do we need to, what problems are we solving with MIDI? How's this going to work? How are we going to use it in our synthesizers? That last one's the big thing, is once MIDI was done, they kind of pushed for its adoptions and implemented it in their devices in order to help popularize it. Again, massive summarization right there. Check this out for a bit more in-depth information. You should know that, hey, it came out of Roland, Oberheim, Moog, and Sequential Circuits, or Dave Smith, or kind of the big players in that. Outside of other corporations were also involved, but they're kind of the big ones, at least in my mind. So once it came about, it didn't really take that long to catch on. It was very popular very quickly. But there was a little bit of iffiness to that, particularly in terms of different corporations and people that, companies that make instruments. They didn't want to adapt a standardized thing. They wanted to do their own proprietary stuff, or they wanted different specs to do different things. But eventually everyone kind of, with some minor revisions, or just was like, well, if everyone else is doing it, we might as well, kind of a thing. Everyone kind of agreed to it and adopted the MIDI as the main standard. And so by the mid to late 1980s, most devices on the market were MIDI compatible, but MIDI isn't done just yet. So there's still a little bit more growing pains to get through. Before we talk about that, I just want to briefly talk about what even is MIDI. I've been saying those two syllables this whole time. So I'm going to break down, generally speaking, what it is. Just know that, again, later we'll deep dive into that. So MIDI is a data protocol designed to communicate information to an electronic musical instrument. Stands for Musical Instrument Digital Interface. I'm just going to say MIDI because that's a mouthful. The thing to take away is what I have typed in all caps right here. MIDI is not audio. If I hear you say that in my class after we've gone through this lesson, why you're probably not going to be passing the class if you just don't understand that concept. MIDI is just a stream of data. Saying MIDI piano, MIDI trumpet, MIDI saxophone, that's not a thing. That does not exist, and it will never exist. As I say, I will die on this hill. What people would think of as, MIDI saxophone is a synthesizer that is being triggered with MIDI. That synthesizer just happens to, usually sound like crap. But that's a whole other argument. So MIDI is controlling a synthesizer. It is just a little packet of data. There's no audio involved at all. Okay, it's just a stream of digital instructions that tell the synthesizer what notes to play and how to play it. That's it. All right. Hopping down here, the MIDI ports that are used. Most modern devices will use a USB, either A or C connector. We'll talk about that later. But you've probably seen, even if you didn't know what it is, these little 5-pin DIN connectors on different devices. This is a MIDI port here, and it uses, again, it's this 5-pin connection. And again, we'll deep dive into that in the future, but they're a lot less common now, but they're still out there. You'll see a lot of synthesizers or high-end MIDI controllers, things of the like, that still use these ports. And the reason for that is because going all the way back to when MIDI was released in 1983, it is still compatible with any other MIDI device that uses this. Like, MIDI predates USB, but if you've got a USB to MIDI adapter, or you just with a MIDI cable, just plug it in, still works. I have at home some really old synthesizers from probably the early 90s, and it's hooked up into my modern PC just with a MIDI cable. It's that easy. Okay. And then just as a side note here, and it'll come to play in a future slide, that because it is a digital protocol, it's just ones and zeros, you can control these synthesizers with a computer. MIDI interfaces existed, or some programs would actually use MIDI to then communicate with the synthesizer to create the sound. So a lot of games and the like would have MIDI soundtrack, and it was, in most cases, a significant upgrade over the previous audio coming out of the computer. Speaking of that, the reason I brought that up is because I've got a video here that is showing general MIDI, but it's using a game to do that. But general MIDI is very handy. I mentioned that MIDI is a standard protocol. That means that it is a set of instructions for the manufacturers to say, hey, here's how we communicate. Just like USB or CD audio, things like that. It is a set of instructions that in order to be a USB device, it has to follow the USB protocol. A MIDI device has to follow the MIDI protocol. All right, that's where we are so far. However, how the devices take in that MIDI information and use it, that's up to the manufacturer. It can be whatever they want once they get the MIDI data. That's really cool and really flexible. That's awesome, but it becomes a little bit of a problem. So let's say you've got your MIDI file that says, okay, here's how we play this track for this game. On one computer, it may sound one way, but on another, it could sound different. And on other devices, as you move it between different brands, they're going to sound a little bit differently from each other. A portion of that is because they just have different sound fonts and files that they're triggering with the MIDI. That's all different, but a bigger part of that is, and I summarize it here, is that let's say you get a thing that says, hey, play MIDI note number 1 for 300 milliseconds. Whatever that MIDI note number 1 is going to be different. It could be a piano on one thing, it could be a trumpet, it could be a bass drum, who knows? It could even be a, hey, mute the thing. It could, all kinds of stuff. There's no standard after the MIDI data gets into the device. This is where general MIDI starts to come in. Outside of just being a general update to some of the capabilities of MIDI, it is a way to help standardize how the devices also interact with MIDI. So, MIDI program 1 is grand piano in general MIDI. Anything that says general MIDI on it, that program 1, that piano, it's always going to be the same. The specific sound timbres involved are going to be different between the different devices, but it's always going to be, the grand piano is this setting, the guitar is this one, and so on. It's just a standard way to help organize it and make things consistent throughout the market. That's the implementation of general MIDI. I got a video here that just kind of explains that and hops between like 5 different MIDI modules just to show that off. And this is going to actually be the end of this set of slides. Again, I cut out all of the video playback. It's probably going to double the time in class, but the next thing we'll talk about is, okay, we know where it came from and generally what it's doing, but how is it doing it? What's actually happening? And that's going to be what we talk about next. Hey, what are the specs? What's going on? All that kind of thing. So that's all I've got for this one. If you have any questions, feel free to stop by my office hours, shoot me a message. I'd love to help out just however I can.